The phrase, "the final frontier," is commonly linked with the exploration of outer space. However, it equally serves as an apt description for certain areas of physics, which continually challenge and expand our comprehension of the universe. Join me as I dive deep into the world of physics to look into its deepest mysteries. This is perhaps the biggest unsolved problem in physics. It seeks to reconcile quantum mechanics, which governs the behavior of tiny particles, with general relativity, which describes gravity as the curvature of spacetime. Finding a theory of quantum gravity would revolutionize our understanding of the universe at its most fundamental level. One approach to this, called digital physics, provides for a way of solving this problem based on the concept that the universe is fundamentally an information system. Comprising approximately 95% of the universe, these enigmatic substances remain largely unknown to us. Grasping their nature is essential for comprehending the development and destiny of the cosmos. It's important to highlight that dark energy is primarily introduced to account for the observed accelerated expansion within the framework of standard Big Bang cosmology. One issue may stem from the fact that the Big Bang cosmology presumes an unbounded universe. Alternative models, such as a bounded universe, can also interpret Type 1a supernova data without the requirement for dark energy. What exactly is time? Why does it appear to move in a single direction? These profound questions continue to challenge physicists. The second law of thermodynamics and the collapse of quantum wave functions offer potential explanations. How did the universe begin? What happened in the first fractions of a second after the Big Bang? These are questions that physicists are trying to answer using a combination of theory and observation. Digital physics, and specifically the information universe, explain the origin of the universe, because if the universe is an information processing system, it had to have had a highly intelligent programmer. Ultimately, maybe this is not a problem for physics to actually solve. After all, at its heart, this is a highly religious question. Are there limits to what we can know about the universe? Are there inherently unknowable phenomena? These are questions that philosophers and physicists have been debating for centuries. One area where physics is likely to have limits is when it starts getting involved with subjects that are ultimately religious questions. In conclusion, these are just a few of the many exciting frontiers in physics. The field is constantly evolving, and new discoveries are being made all the time. Who knows what secrets the universe still holds?